All right, we continue with our quest on working with inequalities. We're going to work on solving problems involving inequalities. So that's like our application or our real-world problems solving this. The age of a tree is at least 70 years old. So my age has to be greater than or equal to 70. We can see our at least 70. Let's consider the rent. The rent, R, is no less than $400 per month. It's no less than that, so that means I'm looking for a number that is greater than that or equal to $400. If the rent is no less than $400, I can think of a number just a little bit bigger. I can think of 500. 500 is no less than 400. The price of a book is at the most $5.95. The price of the book is at most that much. So my price is going to be $5.95, but it is going to be less than or equal to that because it is at most that price. Here's my 95. And let's take a look at a race. Her time, so let's use time as T. Her time in the 10-kilometer race, not useful information, was no more than 40 minutes. It was not more than that, so my time is less than or equal to 40. Let's take a look at a problem here. Molly set her car's odometer at 0 at the start of her trip home. The odometer showed that she had driven 16 miles. This looks important here. A highway sign showed her that she was still more than 25 miles from her home. What is the minimum total distance to the nearest mile that she'll have traveled when she's gotten home? Well, it's going to choose a variable, so we're going to do a let statement. We're going to let D equal the total distance in miles. So we got our let statement. And then the distance to the sign from home is going to be the total distance minus the 16 miles they've already gone. So that equals the distance from the sign. To home. All right, so this sets us up. Now we can solve here, and we know that the distance from the sign from home, so the distance from the sign to home is greater than 25 miles. If I go ahead and solve that out, I can see that my distance from traveling is greater than 42. Actually, it's 41. So my least number of distance, so let's stick with the question. The minimum total, okay, so the question I'm looking for, the minimum total distance, if my distance has to be greater than 41, then my minimum total distance that I had to go on would be 42. So my answer would be 42 on this one. All right, let's try another one. Mike here wants to rent a car for his vacation. The rental costs $125, so it's $125 per week, plus $115 per mile. So I got a bit of a rate going on here. Some addition, all cost there. How far to the nearest mile can Mike travel if he wants to spend at most $200? So this is telling us a few things. So we're going to try a let statement. So we're going to try to let, what are we trying to solve for? It looks like miles here. So let M equal the number of miles Mike can travel. Okay. Now let's see, the cost of the car rental is at most $200. So the cost of the car rental, the cost of the car rental, and I'm getting this from up here, is at most $200. Okay, so I can build my statement from this. So my $200, it needs to be, so the cost of the car rental is at most $200, so my left side of my equation needs to be less than or equal to $200. The rate is 125 per week plus the 15 cents per mile. I'm going to pause and finish this out. After working this out, I can see that the minimum number of miles that he can go is 500 miles. Actually, that's at the most. So his mileage is at most or equal to 500 miles. All right, let's look at computer screens. Let's see, so the width, the computer screen is 20 centimeters less than, I'm going to keep that in mind, twice the length, okay. And then we've got the perimeter is at least 53 centimeters, okay. Find the minimum dimensions, okay. So we're finding minimum dimensions of the screen that this works out, okay. So for this one, I'm going to use kind of a drawing maybe to help me see this one, because I've got the width of the rectangle machine, okay, it's 20 centimeters less than twice the length. So it's all dependent on the length. So if I know the length, then I know the width is going to be twice the length minus the 20 centimeters. So that's twice the length, not 21. So twice the length minus 20. So we're going to do let L equal the length in centimeters. And then this will mean that the rest of this 2L minus 20 equals the width in centimeters. All right, that being the case, the perimeter is at least 53 centimeters. If the perimeter is at least 53 centimeters, then I know that my left side has to be greater than or equal to 53. So this whole side, I'm going to do, I've got my length, so it's perimeter, so I'm going to double my length to include both of these pieces. And then plus, I need to double my width. So I'm going to double my width. All right, let me pause, work this out, and see how you did. All right, when I worked through this problem, notice my symbol did not flip. I did not multiply or divide by a negative number. But when I distributed, did my addition property of equality, my division property of equality, I worked through and I see that my length needs to be greater than or equal to 15.5. But when I look at the original question, so it seems like it could be just a little bit bigger than that, but let's look at my original question. It says I need to, needs to be an integer, okay, so no more decimals on this, and I want the minimum. So I want the minimum integer, so when I play through this one, L is greater than or equal to 15.5, that would mean my answer is 16 centimeters. So be careful that when you're working through the math that you also go back to the original question to make sure you're solving the question that's being asked. The key of making this lesson work is to really slow down and look at all the pieces of it. Keep track of all the details, write it accurately, make sure you use the correct inequality symbol, and simplify well. Keep track of those details. All right, I'm going to go find a stray cat to play with. Bye-bye.